Good evening, everyone. Um, I'm here. My name is Naresh Menon. I'm Director of Product Management from Imagination Technologies. I'm here to present to you our Catapult product line, which is the RISC-V CPU course, which we launched in December last year in the RISC-V Summit. So just to give a background about Imagination has predominantly been a GPU company which used to sell a lot of GPUs, and it is basically an IP company. But we have started growing into different. We have broadened our IP portfolio into by bringing in a network accelerator, a neural network accelerator, and an Ethernet packet processor. We are currently in 2020, we were at $125 million of revenue, which was plus 44% of revenue growth year on year. We have a strong market share in the automotive industry, which is 53%, and the mobile, which is 35%. This is all on the GPU side. Uh, the the next big thing for Imagination is to bring in a CPU from Mars Staple, and that is what we will be delving more into details. Imagination's business model is like a classic IP licensing model, where Imagination creates an IP, licenses the IP to a chip vendor for a licensing fee. The chip vendor in turn creates an SoC and gives that to the OEMs, which brings out the end product by putting in that chip for whatever function it's used for. The customers buy the end product and buys it for a price that in turn triggers royalties per unit to a chip vendor, which in turn gives royalties back to Imagination as an IP company in terms of the utilization of the technology at the end product. So basically, in a nutshell, we get revenue from both licensing fee and some bits of royalty. This slide is trying to show you that what our Imagination team is comprising of, which is 800. We are greater than 800 employees worldwide. Particularly for the CPU team, we are about 150 years of experience in terms of building high efficiency CPUs. We will be greater than 100 dedicated CPU engineers in 2020 and growing that to 200 within 2023. The engineering is based mainly in the UK, which is having 3 centers across Bristol, Cambridge, and Kings Langley. Kings Langley is our headquarters, but there are other centers as well where we would be developing, what we would be contributing to the development of the CPUs, which is Romania and India. The team will consist of hardware. The team consists of hardware, software, modeling, and toolchain engineers. And the team is highly motivated and a very energetic team, which will be creating these CPUs. We have access to a lot of fundamental CPU patents from our historic development and M&A. But also we have thousands of own technology patents and the only non-US core GPU patents. We also have patents across the other IPs like GPU and NNA. So our strategic focus is mainly to four four segments. First being the automotive, second being the mobile and consumer space, third being the DCD space, and finally the compute. Where compute is, you can think of, going into each of the first three major segments, which is the automotive, mobile, and consumer and DCD. So the automotive space, we are the market leader in HMI GPU. We have technology for ADAS AV and leadership in that with AI, GPU, and compute. We have high performance Ethernet solutions for automotive, and all this is done with functional safety underpinning these IPs. In the mobile and consumer space, we have leadership in GPU and ray tracing for ultra and sub-ultra mobile. The GPU scalability is to high volume handsets, DTV, STB, OTT, and other consumer devices. And in the DCD space, we have leading GPU. We are a leading GPU IP supplier for DC and PC and data center. We focus on cloud gaming opportunities worldwide, and Imagination scalable GPU enables customers to disrupt current hyperscaler supply chain. So this begs the question, why CPU and why Imagination is interested in a CPU again? This is because we recognize the importance of a CPU because it defines the architecture and structure of the SoC. It defines the security model of SoC, meaning that it defines how applications works on the SoC. We recognize the key trends like the Moore's law's ending, which is going to end, which is driving heterogeneous computing solutions as going to be the next step in the future. We also understand that the industry is looking for alternate solutions in the RISC space, where RISC-V is emerging as the leading ISA competitor. And finally, we recognize the opportunity which Imagination can get in terms of alternate leadership in CPUs, leadership in heterogeneous computing, and as well as enhanced or increased revenue and market share. Our CPU history is 20 years ago, as we have built Meta CPUs, which were multi-threaded CPUs, debuted in 2001. And we had MIPS through an M&A in 2012, which we launched 3 new core families, shipped in greater than 3 billion CPU devices. Our experience for building CPU is with a team which is excellent in terms of both experience in building high efficiency CPUs, but also energetic in bringing in newer and innovative technologies. We also plan to grow the team in as 3x from where we were in 2022. We have extensive patent protections from over 500 CPU patents, and this differentiates also us from other RISC-V suppliers. We have backed the RISC-V ISA as the ISA to go into the future because we expect that there's more innovation going to happen because of the open ISA, because of it being an open ISA. We believe that this would be a modern architecture which would be scalable for AI and ML architectures. We appreciate the custom extensions it provides. It could provide for unique use cases and operations. And finally, the last but not the least, the ever-growing and broad, rich ecosystem which RISC-V will and has already enamored. So, like I mentioned, the heterogeneous compute solution is going to be our final end play, where the CPU is one of the fundamental pieces. But to just put the picture in your minds, we compare the heterogeneous compute system to the most complex heterogeneous compute system in the world, which is our human brain. The human brain takes in various different images from the environment around, processes it, defines what are the kind of what is the kind of activities it needs to it needs to fulfill, and uses different aspects of our human body to do those activities. Same thing, putting the same analogy, we recognize that the heterogeneous compute solution will need distinct processor architectures. It will be working on diverse workloads, and it should be as simple as possible to be deployed. We also expect it to be flexible, efficient, and resilient. So now this slide, from now on, we will be introducing the Catapult CPU product line. This is designed from grounds up for the next generation heterogeneous compute needs. It is configurable for performance, efficiency, or balance profiles, making them suitable for a wide range of markets. It is leveraging on Imagination's 20 years of experience in delivering complex IP solutions, and also it's supported by our rapidly expanding open standard RISC-V ecosystem. This will be divided into 4 distinct families. First being the dynamic microcontrollers, which will be used for ultra low power and ultra small, ultra low power and ultra small cores for embedded and microcontroller applications. The second one being the real-time embedded CPUs, which would be highly scalable, mid-range, feature-rich cores for mainstream devices. The third being the high-performance application CPUs, which would be high-performance cores for demanding applications. And finally, the functional safe automotive CPUs, which would be all of the above CPUs, but with added functional safety features and processes added to the development. We are already shipping in our high performance automotive GPUs in SoCs from Imagination customers. The real-time embedded CPUs will be made available now, and the high-performance application CPUs and automotive CPUs will follow from 2022. The Catapult CPUs are engineered for markets ranging from 5G modems, storage, ADAS, AV, data center, and high-performance computing applications. It can be used with GPU, EPP, and NNA IP in flexible arrays of high-performance compute elements that meet exacting power and efficiency requirements. There will be full hardware, software, and debug support for SoCs using Imagination IP. And it will be compliant with the ratified RISC-V ISA and fully supported by the broad and increasing RISC-V ecosystem of software and tools. This on the right is the Catapult product line's block diagram. It is having both 32 and a 64-bit variant. It will have a multi-threaded variant as well. This is highly customer configurable. It will have a multi-core variant which could be up to 8 asymmetric coherent cores per cluster. The automotive variants will be developed to highest integrity level in terms of the ISO 26262, and the CPUs will be based on proven security concepts such as a robust secure boot and mechanism for isolated and secure execution environments. And it also enable vendors to integrate their own root of trust and cryptographic technologies to meet the highest levels of security requirements and certification required for their target markets. These CPUs will have private L1 caches and also TCMs, and they all will be enabled with ECC. There would be optional FPU, which will have both single and double precision, and MMU and MPU depending on whether it's a real-time or an application core. The multi-core variant would have a shared L2 and a coherence manager, and the debug and interrupt controllers would be shared across as well. This slide is showing the direction of travel in terms of how the CPUs will be developed, where the first on your left-hand side is the 32-bit in-order real-time embedded processor, which would be specially made for SoC helper cores, embedded gateway, or storage applications. Following which, there would be a 32-bit multi-core variant of the same, but with vector support added, which would be useful for a 5G modem, and also vector for the DSP and AI applications. In the middle, we would be developing a 64-bit in-order multi-core application processor, which would be capable to run a rich OS like Linux, and would could be used in edge inference applications as well. Finally, we would have a 64-bit out-of-order high-performance multi-core application processor, which could be used in the mobile AP and cloud compute applications, which are in the high-performance space. All of these CPUs will be refreshed for the next generation heterogeneous compute solutions. And the key takeaway from this is that there would be automotive variants of these, plus that they would be developed to the ratified ISA, so that you as a customer would have access to all the broad and rich ecosystem we have. We will also be delivering an SDK and IDE environment, where the SDK will have both support for both LLVM and GCC and a GDB debugger. The IDE will be based out of Visual Studio Code and would be available to run on Windows, Ubuntu, CentOS, and macOS. We will be providing full Linux and free RTOS support, and it will be compatible with Gem 5 software as well. We have a university program which is a very well received one in the market, which is the RFPGA, which is an RFPGA course, which is understanding computer architecture. It is used to target this teaching package is to target a commercial RISC-V system on a chip to an FPGA. It will help program the RISC-V SoC and also add more functionality to the RISC-V SoC. The RV FPGA package also supports a comprehensive, freely distributed, complete RISC-V course, a hands-on and easily accessible way to learn RISC-V processors and ecosystem. And also it is targeted to low-cost FPGAs, which are readily available at many universities and companies. This will be available in Japanese as well, and comprises of 25 labs and enough material for three semesters of teaching. This demonstrates Imagination's commitment to this once-in-a-generation technology. So, what if you already have a CPU? You could take the other IPs which we have, like the GPU, which is world leading, and we also have an AI, which is the NNA, high performance, low power neural network accelerators, or for connectivity, you could use the Ethernet packet processor, which is the high performance Ethernet solution. All these could help in building your heterogeneous SoC. So why work with us, and why take a RISC-V CPU from Imagination? It is because of our pedigree. We know how to develop and deploy complex IP solutions. We have a very strong support function. We have complementary IPs to build a heterogeneous compute solution, where we have a GPU, NNA, and the EPP. And finally, the last but not the least, the right levels of protection, because we have access to a lot of fundamental CPU patents, and which would give customers a good night's peace of sleep. So in summary, uh, the Catapult product line will have four distinct families, which is the microcontroller, real-time processor, application processor, which is high performance and efficient as well, plus the automotive processors, which would be all the above processors with additional functional safety capabilities. We are a major new entrant to the CPU market, especially in the especially helping taking RISC-V forward. We have a very proven, world-class proven support system. We have a lot of our team has a lot of experience in building high efficiency CPUs. We will be creating functionally safe CPUs as well, and we will be taking care. We will be having end-to-end security as well in mind. The CPU quality will be very high because we will be verifying it uh, from the from the unit level all the way to the top, and then putting it into system context as well. And we would be supporting the wide ecosystem, and also putting ourselves in the forefront of championing the RISC-V initiative and RISC-V International as well. We will have a lot of different business models as well, which would help engage with us, and we are open for lead partnership as well for our CPUs. Thank you for giving this opportunity, and we are waiting for engaging with you as a customer in our exciting journey forward.